Hey everybody, and welcome back to another video in this series. So in today's video we will be going over the pure functions that are underneath the movement analysis that are used within the chooser tables, and hopefully I think should be the final part of the event graph related stuff, because they will start being utilized in the anim graph. So I'm hoping to kind of get into the anim graph pretty soon, to try to do some research into that and to also guide y'all through what's going on in there. So let's go ahead and get started and take a look at these pure functions and talk about them as we create them in our from scratch template. So as you remember from the last video when we did the update states, we did make one movement analysis pure function already called the isMoving, where basically all it's doing is just checking our velocity and our future velocity to make sure that we are moving. And if both of those are true, then we are technically isMoving. isMoving would be true, as it returns that value for that one particular branch. If I remember correctly, it should be our moving and idle right here. So what we'll be working on now is getting ready to do the other ones. So we're going to create the isMoving, ispivoting, should turn in place, just landed light, just landed heavy, just traversed, and should spin transition. However, I am going to keep just landed light and just landed heavy more towards the end of the video, just because we do have to create something in the character blueprint in order for it to be called within those two functions. So let's go ahead and get started and work on the isStarting. So let's go ahead and make a new function and call it isStarting. So I'm gonna go ahead and move it in here, and with a lot of these I don't have, with none of them really, I don't have any custom comments to them, because now that we've been going through this, I'm kind of hoping that as I explain it off of the developer notes comments, that you'll understand more or less what's happening now, especially since you can see how we've been putting things together from the character blueprint now to the animation blueprint. So within our isStarting, let's go ahead and get to it. So first thing we want to do off of here is we want to grab, and it should be under essentials, we want to get our velocity, and then we should have, I believe it's off trajectory, the future velocity. And let me go ahead and put that above just to kind of have that one-to-one copy. So what we'll be doing now is off of both of these, we're going to be grabbing the vector length XY, because what we're trying to do is we don't want all parts of velocity together. We want to converge the X and Y values, so that way we get the like the magnitude, or at least a single digit value, not a single digit, but a single value. Like pretty much that's how we've been getting like ground speed. So you will have seen it, in the third person template, or maybe even in the first person template, or here within the game animation sample project, as we've been recreating it from scratch, where anytime we use a vector length XY, you're not necessarily getting the ground speed per se, but we've been utilizing it more often than not of just getting the speed 2D or the ground speed, which is, again, you're just converging the XY values into one value, because basically you're trying to simulate your velocity on the horizontal plane, essentially. So anytime you go on the Y or the X, whatever, you should see like your ground speed set as a single value, rather than it set as XYZ, and then every time you move on the X it's 500, or on the negative 500, or on the Y 500 or negative 500, things like that. We're just making it into one value on the horizontal plane. So we're going to grab this and we're going to copy it, and we're going to hook the other velocity up into it just like that. And so what we're going to do then is we're going to check for some values. So let me go ahead and grab these operators real quick, and I'll briefly discuss what they're trying to do here. So in here, we're going to get a greater than equals off of the future velocity vector length. And then we're going to move it a bit further down, and off of the velocity vector length, we want to get an addition node. And the way they have it set is that they have it set to add 100 off of the velocity. So with what's going on here, what they're essentially trying to do is they're trying to do a compare. because with the is starting, what they're trying to do, so if you recall in the previous video, especially with the update or the generate trajectory and how we were trying to obtain future velocity, because it's trying to see the point, you know, it's trying to predict, you know, 15 frames ahead or 15 steps ahead basically within a matter of like 0.1, you know, second each time, you know, where it should check that as we're moving what our future velocity should be, you know, 15 frames ahead if we continue on that path, or if we're stopping, you know, what it'll be 15 frames ahead of that point. So what we're trying to do a compare here is if our future velocity, so if we're starting in idle and we want to move, so that way we would be technically starting, we're checking to see, and we're giving it a great like a wide berth, or at least a higher value to ensure that, like, hey, within the first frame to the next 14, at any point in time, will we be above, you know, our current velocity, you know, plus 100 up until we get to the max point of our velocity. So if, you know, our future velocity isn't going to be greater than our current velocity plus 100, then we are starting to move, you know, at that point in time or that frame. So obviously, you know, once we do start moving, once we actually get up to speed, this will, you know, no longer, you know, have any effect, because, you know, we'll always have just a higher velocity than our future velocity due to this addition. So you may have noticed, you know, in the chooser table, where you'll probably have noticed that the is starting, I believe it shows green when you do a debugging, or if you're moving regardless, because it's like, you know, you have a higher velocity than your future velocity, so but regardless, because you're moving, you know, I think it highlights green. So off of that, then what we're going to do is we're going to right click into this space and grab an and boolean. And what we're going to do is we're going to add a pin to it, because what they have going on now, since we created it in the last video, we are going to grab our is moving pure function and actually attach it into this first spot here, because we want to check that, are we moving, are we starting to move, you know. And then what we're trying to do for the final pin is we want to grab our current database tags, and we want to drag off to see if any of those tags contain a pivots tag. So the reason that we're trying to check for this is because with pivoting, you'll have noticed it in the game animation sample project. So let me do this real quick. Let me move it over here so you can see that when we start. So what pivoting is all, oh yeah, you'll probably have noticed that I've been trying to work on something for y'all, but you know, to get back to the point, you'll notice, you know, pivoting, to pivot, you would go in the opposite direction. So notice how he did those like subtle movements or sudden movements, the way he's shifting, because that's technically a pivot where you're going in a positive in like one direction, or maybe a negative in one direction. So like your backwards would be technically be negative, your forward would be positive, your left would be negative, and your right would be positive. However, with this sudden shift of going into the opposing direction, you are pivoting. So even in real life, you know, say you're running down track, you've probably done it in school in gym class where you've done relays, right? Where you have to run all the way to the end of one side and then run all the way back. What you're doing at that end of the track is you're pivoting back, because now you have to do the sudden shift backward in the or going back in the opposing direction from whence you came. But it's that initial transition backwards that is the pivot, because once your eggs out of that pivot, then you're just, you know, running back, you're just running back the way you came. So that is what we are trying to look for, is to see if our current database tag contains pivots, and if it does, we want to inverse that decision. So we want to grab a not boolean, because we want to set it to false, because it's pivoting. So if the database tag contains pivots, then that would be, you know, a true scenario in this case. If it contains pivots, it's true. So then if it is true, we want to inverse it with a not Boolean so that it means false. But in this sense, what we're trying to do is, if it lines up, all true, then, we are starting. So I guess in a sense, when you do move back, you kind of are starting, but also too, in this sense, you are starting regardless because the velocity is like higher than here. You are moving, stuff like that. So I may have explained it poorly with the pivots part, but all we're trying to do is, if we don't find a current database tag that has pivots. So if the database tag, that we find is not pivots, then it would be false. And then we invert it to true. And then all these would then be true if we, have a greater velocity, we are moving, and the database tag does not contain pivot, So if all those are true, then, we would have, let me see, let me get a return node. Then we would have true, and we would be technically starting. So let me go ahead and feed that in there, and that will finish off our first part. So hopefully I explained that well enough. I feel like I explained it poorly with the pivots part. All we're just trying to do here basically is that, so basically going off the dev note where, this function is used to determine if the character is starting to move by checking if the future velocity is greater than the current velocity. If the current database asset is a pivot database, this function will always return false. This prevents motion matching system from interrupting a pivot since the second half of a pivot is very similar to a start. So that's what I was trying to explain. So I felt like I should read the dev note to, basically explain that part. So basically, like it said, a pivot is similar to a start because as I showed you in the, the brief gameplay that I showed you when we did a pivot, you are technically kind of starting when you move in the opposing direction because it forces your velocity back down to then come back up in that direction. So it will act like it will act like an is starting. So if you didn't have this, then basically anytime you pivot, it would be interrupted by the is starting because they're very similar in how they start when you go in a direction. So hopefully that made sense. Like I said, I apologize if it didn't, but let me know down in the comments if it was confusing so I can try to better explain it there, because I feel like I'm a bit better with the written part of it compared to the speaking part, but let's go with it. So let me go ahead and move these back real quick just because I feel like they're a bit out of place. So now we have our second pure function, but before I end it here, I forgot that we do need to make it pure. And like we discussed in the previous video with how to make a thread safe function, as you can see, all of these are referenced elsewhere, so that way we can just pretty much get all the basic mathematical operations, because technically this is a mathematical operation. In math there are things called arrays. So, it is an actual thing, but because of how we're referencing it in here and stuff like that, we are doing pure operations in here, so we can deem it thread safe, and this should work now. So now that we have it as a pure function and as thread safe, we can now call this within the motion matching database. So now that we have done that, we are ready for the next part, which is the pivoting. So let's go ahead and open that up and create that, and let's discuss it, because I do have, a different way of pivoting as like a basic example of it. I may need to pull up my notes in regards to it. Hopefully if I can find it, I should have it somewhere. But basically what we can do, and I'll show you in just a bit, is that you can use what's called a dot product, but I'm not going to get into that right now. Let's go ahead and put the is pivoting together. So for the is pivoting, it's going to be similar to how we did the velocity, where we want to grab our velocity and we want to get our future velocity. Because, for the pivoting this time, we're not going to be getting movement. What we're trying to do is gather rotation, because I like the way that they're doing it in here compared to a dot product, because a dot product is kind of confusing, but like I said, I'll explain it in just a bit. So with what they're doing with future velocity and velocity is they are grabbing a rotation from X vector for both of these nodes. So basically what they're trying to do here is, however, they're rotating, or you're rotating around the X vector. So as you can see, returns the FR rotator orientation corresponding to the direction in which the vector points, sets yaw and pitch to the proper numbers, and sets roll to 0 because the roll can't be determined from a vector. So even though I said rotation from X vector, because with rotation on the X, it is considered a roll. So, I think I mentioned it in one of the videos where a roll, imagine you're flying a jet and the jet is going in a straight line, and then all of a sudden you do a barrel roll. Like, you don't move left or right or anything, you just do a barrel roll. That is essentially what a roll is in rotation, is you're rolling across, like you're rolling around that axis, like horizontally. So, a yaw would be a rotation around the Z axis. So the Z is an up and down axis. So basically imagine, and I know it's a raunchy way of saying it, but imagine rotating around a stripper pole. That is essentially what a yaw would be, is you're rotating along the Z. So I know it's a little raunchy, but that's probably the best way of thinking of what a yaw is. And then a pitch. So we've explained what a roll is like you're doing a barrel roll on a horizontal, axis, and a yaw would be around, the Z axis. A pitch would also be, you're not barrel rolling, but you are rolling around on a horizontal plane. However, you're doing it, imagine like you've probably seen it in like cartoons, or maybe your parents used to talk about like the way they had fun growing up, and you've probably seen it in movies where, somebody would get into like a tire tube and roll down a hill, right? As fun back in the day. That would be like probably a better example of what a pitch is because it's a forward flip, or maybe like a front flip into a pool, or a back flip into a pool. That would be a pitch because you're rotating along the Y in that fashion, because you're not barrel rolling, you're back flipping or front flipping, or like rolling forward in a tire, maybe, something like that. So what we're trying to do here with the rotation from X vector is that we're trying to set the roll to 0 because we can't determine it from our vector. So we're trying to get other parts of this. So what we're essentially doing, so let's go ahead and grab off the next part to get a rotator, a delta rotator. So what this says is normalized A minus B. So off of here, we're going to split the structure pin, and what we want to do is grab an absolute float on the Z, because what it's trying to do is we're using everything else off this, primarily the Z, into our delta rotator and grabbing an absolute, because what we're trying to do is check our how we rotate or pivot like along a certain degree. Like they mention like 45-degree pivots. So it's kind of hard to explain, but basically think that you're running forward, and with this setup that they have going full, like if you're running forward with this setup, then as soon as you turn around, or you quote unquote pivot, like how I showed you in the demonstration, then this acts up to get our rotation around the Z, or how it was doing that, So that's how they're grabbing it here. And then what they're doing with the absolute is because when you do a pivot or delta rotator, you're going in the opposite direction, so that value, if you did a print string from here, would go like from 1 1 1, and then all of a sudden -1, and then you would go back to 1 1 1. So those -1s indicate like a pivot. So, but we're not using the function that I would typically use. They're doing it a little bit more advanced with like degree angles where, you know, if you're going into like negative degree numbers, then we want to convert that into an absolute. And an absolute, what that does is it always generates you a positive value, because what an absolute float is, or an absolute number in math, is how far away from, I believe, 0 that point is. So if you had like negative 45, 0, and then 45, both points are 45 points away from 0. So that's what it's trying to do in the mathematical sense, is it doesn't matter if it's a negative or positive number, it's just how far away from 0 are those points. So the negative 45 would then just return a positive 45, because it's technically 45 points away from from 0. So I could have been misremembering that. All I know is in that fashion, that's why it always generates us a positive number, regardless that it's negative. So then off the absolute, what we're going to do is we're going to grab a greater than or equals, because the degrees that we're getting from the delta rotator, what we want to do is we want to compare it from the value that we get from a select. And what we're going to do, actually, since I got the wrong one, let me grab this different select, because we need the wild card. So off here, what we're trying to get, and it's going to be one of our states, which is the rotation mode, because what we're trying to do is if our orient to movement, so I wonder why it's not letting me do, how they transform it into that. Bear with me, guys. I will be right back. Alright guys, I'm back. I figured it out. I didn't know that you could do this with a select node, so this is actually my first time figuring it out. So when, you know, in a select node with how they have the wildcards and stuff like that, and especially since, you know, they don't have like floats or whatever, booleans, whatever with, you know, enums, you could apparently just right click on the selection and do change pin type, and then you could change it to whatever you want. So that's how they got the float. So I'm just now finding that out, so I like that. So in here, we're going to set 60 for our degrees and strafing 40 for our degrees. And what we're trying to see here with our delta rotator is to see if our positive value from our rotation is greater than or equal to our orient to movement or our strafe. So, you know, if it is, then we do, what is it? I think we do the pivot if it is greater, and then if it's not, we don't. So, like, you know, according to their notes that they have, the dev notes, is this function is used to determine if the character is pivoting by checking if the character's future velocity is moving in a much different direction than the character's current trajectory. The rotation modes have a different threshold, since 45-degree pivots work nicely during strafing but are not necessary during orient to movement. So, I guess in a sense, the pivots are probably more in line with the orient to movement, just because of how you're facing. So if I were to actually do like a test play, right, and let's like orient to movement, so I'm moving around, as you could see, yeah, see how I'm pivoting now? So I guess if we're not greater than or equal to, then we're pivoting just like that. Yep. So I think that's what they intended there. So I guess I misinterpreted that part pretty wrongly. So I apologize for that. But other than that, we've got our pivot set up and we know what we're checking for. So now all we have to do is grab a return node, plug that into there, plug the execution pins, and then we need to just make sure our function is pure and is thread safe to be called in the motion matching table. So now the other way, so let me see if I can find my notes real quick, guys, and I will be right back, because I want to show you kind of like how the pivot with a dot function is. Alright guys, I am back and I have a basic setup for what I used for in his pivoting function before. You know, before I started using this version of it. So basically what I'm doing here, and I basically am utilizing the essential values that we have set up in here since they're already set, is as you can see, I'm grabbing the acceleration which is the current acceleration we set up in the essential values, and then the velocity. And what we're doing is normalizing both of them and then feeding that normalized value through a dot product. So now with the normalize, essentially what this is doing, especially with the tolerance value, so the notes that I have for it is the tolerance value and the normalize function helps avoid errors when normalizing vectors that are already very close to 0, which would help normalization or make normalization impossible or result in numerical instability. So a tolerance of 0.0001 means that if the length of the vector is smaller than 0.0001, the engine will treat it as a 0 vector and avoid attempting to normalize it. So that's what the tolerance part is. But the normalizing, so the purpose of normalizing the vectors is to ensure that the vectors are unit length or a magnitude of 1. So basically, like whatever the acceleration is, it's just going to set it to 1. Whatever the velocity is, set it to 1. And then what the dot product does is it compares those values against the threshold. So if the dot product value is close to 1, the vectors are aligned, no pivot. But if the dot product is close to -1, the vectors are opposite, meaning your character might be pivoting. So what it's doing is comparing like opposing values. So, or let me explain it. I have other notes that explains it better. So a dot product is a mathematical operation that takes two vectors and returns a single scalar or a number. It provides information about the relative angle and direction between two vectors. So what it's doing is getting the cosine of the angle between vectors. So it is trying to effectively calculate the cosine of an angle between the two vectors. Then this is why it gives you, a result like based on how aligned or opposed the two vectors are. So if the cosine between these two normalized values is 1, then that means the vectors are pointing in the same direction, which means that there's no pivoting. If the vectors are perpendicular, so say you're running forward and then all of a sudden you just take a left turn, that you're perpendicular now, and that means that the cosine result from the dot product will be 0. So, no pivoting is occurring, you just moved at a 90-degree angle. But then if the value is -1, then that means the vectors are pointing in the opposite directions. So what it's essentially trying to do is your acceleration is going to happen before your velocity, because your velocity is a speed in a specific direction. So like I've mentioned this example I think multiple times in my videos, where say if I'm moving north at 50 miles per hour, then my velocity is northward 50 miles per hour because it is a speed going in a direction. You need both of those for it to be a velocity. If I just say I'm going 50 miles per hour, then that's not your velocity, that is just your speed. So you have to have direction and speed. That's why when you split velocity or get other stuff from it, that's why it also has like a rotation to it, because it's your speed and a direction. Acceleration is just a speed, but it's a thing that basically gets you up to speed. So what it's trying to do is compare the acceleration to the velocity with a dot product. So if you start accelerating in the opposite way than your velocity, then you will result in a negative number or a -1, which means you're pivoting. So that's why I was using this version more often than this one, because I find this a bit simpler. But because of how in-depth the game animation sample project is, I would pretty much kind of prefer this way, especially with how future velocity works and how they're actually trying to, get the delta rotators and get angles and checking if we're greater, than the strafe or in less than the orient to movement with our rotation. But this is another alternative in case you did want something simpler. So hopefully I was able to well explain that, and I do apologize for a lot of like the stuttering and stuff like that I've been doing. It's just I'm trying to wrap my mind around like how I can best explain these things. So I'm going to go ahead and delete that and then save. And now we can continue on to the next one where we're going to do the should turn in place. So let's go ahead and go back up here and do the should turn in place. And then move that into the movement analysis. So now in here, so with the dev note in here, so this function is used to determine if the character is turning in place by checking if the root bone rotation is different from the character's capsule rotation. For this project, if the rotation is greater than 50 degrees and the character is currently aiming, the character should be turned in place. We also allow turn in places to play the character has just stopped, which gives us a stick flick behavior. Turn in place behavior during the aiming state is still a work in progress. Additional limits need to be applied to the steering or root offset node to prevent the character from lagging too far behind. So if y'all have seen my aiming motion matching series or like little mini series, you'll probably have seen it where when you try to aim and you turn in place that it lags behind a little bit. So that's what they're referring to in that, second note where it may lag behind a bit, because with how the speed is and also how we're transitioning and how the aiming is working, there's a lot more variables involved with how the character should be turning in place. So that's why you'll see like hands and stuff like, kind of lagging or seem out of place because of that. But other than that, let's go ahead and get into it and get our stuff. So for this one, we want to grab our character transform and we want to do a get, and we want to get our root transform, because now what we're trying to do is we're trying to get our baseline character transform, and we want to split this because we want to get strictly the rotation off of it, and then whatever our root transform. So if you remember with the setting, the updating essential values, how at the beginning we set a character transform and then we set a root transform based on our character transform or based off of the root anim. So in our anim graph, the offset root bone that we had, gotten, in order to check if we should turn in place or at least get the angles from those, or get our rotation and make angles off of them to see if we should be turning in place. So with that being said, with both of these, let's go ahead and grab off of this and get a delta rotator in order to normalize this and compare angles and stuff like that. And then we want to split the struct pin and get the yaw, because again, like I said, with like our rotation as well as what I tried to explain with the pivoting, is when you're turning in place, you're spinning around the Z axis, you're yawing. So like I said, I know it's raunchy, but a stripper pole, that's essentially the closest reference or the most basic reference you can make of how you would be rolling around spinning around on that Z axis. So then what we're trying to do here is make sure that we always return a positive number from it. And then we're trying to see if that angle of it is greater than or equal to 50. I believe it said 50. Yep, 50. And then if that is the case, then what we want to also do is we want to check other values. So we're going to get an AND boolean here. And for the moment, I'm just going to keep that there, because now what we're going to check for is our movement state. So now we actually get to utilize a last frame to also check this stuff. So we're going to get our movement state. Actually, we don't want, or actually, no, we do want that. And then our movement state last frame. And then we're going to grab an equals node off of both of them. So when we want to do the equal enum, not the equal operator, because the equal enum will allow us to get the other parts of the enumeration. So I'm going to go ahead and grab it here. So what we're trying to do is if our current movement state is idle and then we start rotating around, that we check if we should turn in place. Then we want to make sure that our moving, or that our movement state last frame is equal to moving, because one of the things that it mentioned was if the character is aiming, you know, allow to be turned in place. We also want to kind of do like a stick flick behavior, so that's also why we're trying to get them moving. It's mainly for the stick flick part of it, not for the actual like idle part, because you've probably played games on console where when you do a stick flick, you know, to just quickly turn around, but you're not trying to move anywhere, you're just trying to like spin your character around, then it's trying to get that part of it using this enumerator equals right here to play a, you know, should turn in place animation instead. So that's what it's trying to do there. Then what we want it to do is grab another AND boolean. So off of this, we want to grab an and compare these, because we want to see if both of these are true. And then if true, then we're going to go into the next part where we're going to check for an OR boolean, and I'm going to move this connector down here because we want to check our wants to aim, as it was mentioning, where, you know, see, you know, for this project, if the rotation is greater than 50 degrees and the character is currently aiming, the character should turn in place. So either we're trying to do a stick flick here, or we're just checking to see if we're aiming. So what we're going to do, just like how they did, is we're going to grab a property access node, and we should have our wants to aim within our character reference. So we're going to go ahead and go down to character, or at least it should be in here, I believe. Let me see. I think I got the wrong part. No, I believe it was... No, I think it was in character. Let me double check. 1, 2... Yeah, okay. Yeah, I was right. It was under character. I was just being stupid. So we want to grab this. So you'll notice that, you know, in the GASP from scratch, or the game animation sample project, it'll have sandbox character, but this is our sandbox character because that's what we established our reference to as our BP third person character, because that's what has the wants to aim. So we're going to grab the wants to aim out of here and plug it into the first part of the OR, because we're trying to compare this against this to see if one or the other is true. So then if, you know, it comes out true through here on either parts, then we are going to then check to see if both parts are true, whether we are, you know, our root transform or our character transform is rotating and is greater than, you know, 50 degrees, and if we're aiming or if we're stick flicking. So now that we got that, let's go ahead and grab a return node and plug that into here and plug the input into there. And let's go ahead and grab our comment and move that over real quick to clean it up. Boom, just like that. And now we essentially got it, but now because we've made all of our reference calls, we can now do pure and we can do thread safe. So now that we got that, we can go ahead and compile and save. So I guess I should, now that I'm thinking about it, I should explain this. So you've probably seen in one of the previous videos where I was trying to, or at the one for is moving when we're doing the update states, where I was trying to show you that how a character reference is not going to work. I gotta do more research on it, but from what I had gathered from a quick research that I've done, that doing a property access node, you know, takes away the actual character reference and calls the true reference value depending on what we set. So, you know, normally what you would end up doing, you know, in this case would be like character and then, you know, wants to aim, right? You would do it just like this. However, with our character being an actual actor or object referencing node, it's not going to allow that in a thread safe function. However, because with an access property, we're trying to access this specific property off of the character node. So I believe it treats it as this rather than having this attached to this. So it's kind of weird how I read it, but it helped me understand a little bit more that if you are trying to build thread safe functions, you can utilize a property access node as long as you get the specific, point, like, wants to aim or wants to sprint, something like that, that's underneath the object reference. So it's still not going to count the object reference, but it's going to count what we're actually truly trying to get out of it and convert it in there and allow this function to be thread safe. So now that we have that, though, we can go ahead and compile and save. And the next one will be landed light and landed heavy. However, we got to do something first, and that's why I'm saving it for last, just because it's a little bit extra that we have to do in the character blueprint in order to properly call this. So what I am going to do is I'm going to skip to the next part, and we are going to, so let me actually close these down now that we got those built. And so for the next part, we're going to do the just traversed. If I can spell, traversed. Just like that. I'm going to move it into the analysis. So this one is pretty simple, or it's simple as far as what we have to grab, but it's a bit more complex than that. And I will do my best to explain this part, although I have to do more research on it. I didn't have enough time to actually research this. But let me grab all the points that we need real quick, and then I'll try my best to go over it. So what we're trying to do here is we want to grab an isSlotActive and a getCurve value. Off of the isSlotActive, we want to grab a none boolean because we want to inverse whatever it returns, or whatever value it returns. Then off of the getCurve value, we want to check if we are greater than 0. So off of both of these, let's go ahead and get an AND boolean and connect this into the AND boolean, because we're trying to check to see if both of these are true. And then if both of them are true, we're going to go into our return node and return the true node, or the true value, or the false value. So let's go ahead and make our slot name nodes. So it's going to be default slot for the slot name, and the curve name is going to be moving traversal. So with the isSlotActive, basically right here, as you could see, is it returns true if this instance has an active montage in the given slot. AU animmontage that is playing in the slot and blending out is not determined to be active. So basically what this is doing is it will detect, essentially, or in basic terms that I can explain it, that to see if a montage is playing on the default slot node. So if I believe it would be like under the skeletons and stuff like that. I gotta do more digging, but there's a node within our character's skeleton or their slot called a default slot, and I think it kind of encompasses the entirety of the skeleton, but don't quote me on that, because I'm not too far advanced with the animation part as far as messing with skeletons and rigs and stuff like that. I've only done mostly the character functionality and what you're currently kind of seeing in here with the ABP of setting up other functionality in order for animations to play. I've never been good at the rigging part because that's not something I've focused on heavily yet. So what it's trying to do is off the default slot check if an animation montage is playing. So for example, any of those three traversal montages, if they're playing, then it's going to return true. So it's going to return true out of here if the montage is playing, but the not will then convert it into a false, which will then send into the AND node a false. And if this is true or false, then regardless, it's just going to output false. However, if a montage is not playing, then it's going to return a false value and then convert it or invert it using the not boolean into a true. So with the getCurve float, you can see that it says returns the value of a named curve. As far as I'm aware of with curve values, because there's no details that come up when you play with it or whatever, but with a curve float, it is essentially like this, like how we did with a float curve within the character blueprint series. where it would grab that curve name or like a curve float from somewhere, and then compare the value to see if it's greater than 0, and if it's true, then output true to here, and then if the the first pin is true, then pass the true into here. However, I have not been able to find a curve name or value that has moving traversal. I have no idea where it's at, and there's very little information on where that can be found. As far as like my research is done, I'm pretty sure there could be something out now in regards to finding where moving traversal is. However, I have just not successfully found it. So I will have to do an update comment on this video when I have found it, so I can give more information on what it's doing. But what it's just trying to do is get the float value of this, check if it's greater than 0, and if true, it passes into here, and then if the first slot is true, then return true here. So with the dev note, this function is used to select the tail end of traversal animations when blending back to locomotion. For example, if the moving traversal anim curve value is greater than 1, this default slot is not active. Slots are not active when blending out. The characters must be blending out from a moving traversal action. Therefore, this function will return true. The chooser then allows the motion matching node to select from traversal databases for a seamless follow through. So that is pretty much what it's doing. It's like I said, it's checking to see if a montage is playing. If false or true, passes it out. But what we're trying to do specifically here, as the comment mentioned, is that we're just trying to check after the traversal montage is played to then get our respective values. So let me go ahead and copy and paste this comment, and then we need to make it pure and a thread safe function, and then boom, we got that done. So now we can go ahead and close out of this. And then the last one I'll be doing before we get into the heavy part, or not the heavy part, but the the additional stuff that we have to do, is let's go ahead and do our should spin transition. So let's go ahead and create another function and call it should spin transition. Move it into the movement analysis. And then we're gonna be doing something similar, where we're gonna kind of morph the should turn in place and the is starting together for the should spin transition. So let's go ahead, and what I'm actually gonna do, just to kind of make this a little bit easier, is let's open up the should turn in place, because what we want to do is we want to grab the same nodes out of here and put it in the should spin transition, just like that. But what we want to do here is change this value to 130 to check if our degrees on the yaw, if our positive value from our absolute float is greater than or equal to 130 degrees. Then what we're going to do is we're going to grab from our essential values and our variables, our ground speed. So in the game animation sample project, they have speed 2D, but ground speed, since we kept it in this series, is the same thing. So we're going to check if our ground speed is greater than or equal to 150 and plug it into the and then lastly, what we're going to do, and this one I'm going to open up the is starting, is we also want to grab, did not mean to do that. We want to grab this last part right here to check if we have pivots in our database tags, and we want to make a new and plug it into here. So with what this is doing, according to the dev notes, is if the root bone rotation and character's capsule rotations, just kind of like how we discussed in the is pivoting, or no, I think is should start. Yeah, no, I think it's should turn in place. My bad. Are very different while moving. This function will allow a spin transition animation to play. Spin transitions are locomotion animations that rotate the character while moving in a fixed world direction and are useful when switching rotation modes. For example, if the character is running toward the camera using the orient to movement and then switching to strafe, this would require the character to spin 180 degrees very quickly. A spin transition animation would be ideal transition for this gameplay scenario. Currently, we're using refacing starts in place of spin transitions, but plan to provide actual spin transition data in the future release. So, just to go over what they said, or what I read out, is that we're checking to see, our spins, right? So let me play like how it is in the game animation sample project. So as you can see right now, I'm currently orienting to movement, right? So we're not rotating on the Z, because rotating on the Z would be this. Like this would be rotating on the Z if I can do it like this. See how the character is like spinning around like this? This is what I was talking about with yawing. So that's a yaw, as you're rotating along the Z-axis. The only way I could show that would be, to move around, but regardless, what we're checking to see if this rotation is greater than 130 degrees. And if our speed is greater than 150, so with here, I'm pretty sure our speed is at 500, because if you've done the character blueprint series with me, you'll have seen where we set our walk, run, and sprint speeds at, so our top speed going forward should be 500. So then lastly, we're checking to make sure that the current database tags does not contain pivots in them, because they could be very similar. So what they're trying to do here is, since we're running this way, we're technically moving forward with how we have everything set up, right? So we're moving forward just like this, but then all of a sudden, if I do a strafe, you can see how he rotates around. So what they're trying to do is do a smooth transition. So let me show you that, for example, in the, the third person template, since we don't have all that additional stuff set up. So you can see right here how I'm kind of rotating around my character around the Z with the strafing. So if I'm moving around like this, but then all of a sudden switch back, you can see how terrible that looks. It's just not fanciful. It's not demure, So that's what it's trying to do, is prevent that sudden shift by making it cleaner by using a should start transition, or an is starting transition, or like a run, walk, sprint start, in order to smooth out that rotation and, get them into the proper placings, or animation starts. So with that, we can go ahead and then grab a return node, plug that into here, and then we can then call our pure and thread safe function a completed function. So now what I'm going to do is, let me move the comment bubble back into here, or not back into here, let me move it in here. Let me try to back this up a minute, or maybe not. I'm just gonna do that, it looks horrible, but whatever. So save that, and now we can work on the last two, which is the just landed lightly and just landed heavy. However, what we have to do is we have to create a event on landed event in the third person character blueprint, just because they have specific animations playing out. What did I do with them? Oh yeah, we never did it in here on the character series, because I just went over the finale part. So what we got to do in here is we got to set some things up. So what we want to do in our character blueprint is we want to call an event on landed, because we want this event to occur when we land. So that's what this is. So within the character blueprint of the game animation sample project, they're setting some variables like velocity and a boolean for landing. However, what they're also trying to do is, play a sound when you land. That is the primary thing of this within the character blueprint, but they have booleans set in here that they're calling in the animation blueprint in order for the animations to play properly. So that's kind of what I was explaining in, I think, the previous video, where I said you want to make all your functionality in the character blueprint and then call them appropriately in the animation blueprint, so that way you're not wasting space over there or resources, etc. You're doing it all at once here, one time, initializing them, whatever, or doing it on certain events, and then it gets called over there. So what we're going to do is we're going to drag off character movement, because what they've done is they did a get velocity, because they're trying to get the velocity while the character is moving, so the vector node, and then they're setting the velocity. So and they're calling it a land velocity. So we're going to promote this to variable and call it land velocity, because they're trying to get the velocity at current time of landing. So that's why they have this event on landed, because as you're falling, what ends up happening is you generate a Z velocity, right? So however, when you land, you come to a sudden stop. That's why you'll probably have noticed, you know, you've noticed like the different like landings and stuff like that is because of how they have different like clamp values and other stuff like that. So however, in this, let's go forward with it real quick just to kind of get through it. So off the land velocity, let's go ahead and we want to grab a set. No, not a set. We want to grab a get node, and we want to split it. If I can get to it, split it, because we want to grab the Z velocity off this, because what they're doing on the event landed is they're trying to play an audio cue. So what they're doing here, so we can then go ahead and do off that a play audio event. That is what it's called. Let me see, audio event. I probably am missing something. Let me see. Well, technically for the moment, guys, we don't need the play audio event, just because of the fact that what we're trying to do specifically is get our landed velocity and our just landed. So for the moment, what we're going to do is we're going to ignore the audio event, because that just plays depending on like if you landed light and landed heavy, like what audio events should be playing. So since we don't have, or I guess that's a function actually, now that I think about it, yeah, it was actually a function. So my bad, guys, I misled you on that. So they did a get fully audio bank and then play sound at location. But again, like I said, we technically don't need to do that for the anim graph. We just need to grab the land velocity, and we need to make a Boolean called just landed, just landed, just like that. And then we want to set it to true when we land. But then what we want to do is do a re-triggerable delay. So what will happen is, you know, they have it set to 0.3 seconds. So off of, you know, 0.3 seconds, once that has lapsed, it is gonna play this again and then, you know, go towards the end, or at least like stop here and then boom, play again, and then triggers this last event here. So because we don't want on event landed to go from just landed to immediately to false just landed, because that could mess up certain audio cues and certain animations. That's why they have a retriggerable delay, because it stops it right here, it waits 0.3 seconds and then refires in order to complete this set, so that way it smooths out the transition or the event landed. So that's what it's doing here. So this is going to be under movement. So I'm going to move both of these variables to underneath the movement in here. And now we can go ahead and call them. So again, like in the game animation sample project, just the in-between part, they're calling the audio event function. So I thought it was a built-in thing. I didn't realize it was an actual function. I didn't do that much in-depth research with the audio event part. So I apologize for that, guys. So once we have that, we can compile and save and then hop back into our Manning. And now we can go into it where we could start the just landed light, and we can go into plus here. And what we want to do is just landed, if I can spell landed light, just like that, and then throw it into movement analysis. And what we're going to do is we're going to grab two property access nodes, because they're trying to call directly to the just landed Boolean that we made and the land velocity that we just made, without having to throw in the sandbox character or our, you know, third person character. So go ahead and copy and paste that. So now we're going to go bind and we're going to grab our, where is he at? Our character. And then off of here, we're going to look for our just landed. Just like that. And then off of our bind, we're going to get our character again with the second bind. And then we're going to get land velocity. I messed that up. We're going to get land velocity. But we want this second one because we want the actual float value of Z, because what we're trying to do is find the impact point of, you know, our land velocity, like how it's being set on event landed. So we're going to call that specifically. And then what we're going to do is off just landed, we're going to get an and boolean. And then for the land velocity Z, we want to get an absolute float, because what happens is during your jump up, so when you're jumping or technically is falling, when you start the jump, you generate a positive Z value when you jump. So just to demonstrate how that looks, let me find here. I'm just going to move that here because I want specific value. So let's do a print string. Let's grab the land velocity, or not a set. Let's do a get split struct pin, and I'm going to throw it in there. Call it with the event tick. So you can see that it's 0, but when we jump, oh, it only worked with the on landed. So let me actually grab velocity real quick. It would be stat debug. Yep, let's just grab this instead so I can show you. Although I'm glad that it did that on the event landed, but I want to show y'all how it generates a positive number. So when we jump, I like how it's not oh, because it's updating in here. I see what it's doing. My apologies, guys. I like how I'm not thinking things through before I actually play them out. Alright, so let's do it this way. Now we shouldn't have any problems. So now when I jump, you can see how it generated a positive number and a huge one, like off the initial. But then as we are falling, it generates a negative number. So that's where I'm getting that from, is when we fall or on the impact, we would have had a negative number. So if I now grab the land velocity and I split struct pin and get the Z, watch what the number is when we land. You can see it's negative 704. So what we're trying to do within the animation blueprint is we want that 704 to be a positive value using absolute. So then what we're trying to do is we want to do a compare. So we're going to do a less than, and now we have to create a new variable called heavy land speed threshold. So with that, we are going to create under variables, we're going to do heavy land speed threshold. Wanted to make sure I spelled that right. And we're going to call it a float. And what we're going to do with that is we need to give it a value, a threshold that we can compare against, right? So for light landings, you know, when we don't have huge dips like that or drops like that, we want this to be below 700. So let's go ahead and compile and save. So when we are less than 700, or we at least have to, you know, do a conversion, making sure that this is positive as well. So we have to call an absolute as well. We want to ensure that the land velocity Z on our character is less than the heavy land speed threshold that we set. I didn't misspell it. Or not misspell it, but didn't camel case it. So, and if that is, you know, true, then we are going to play the just landed light animations. However, if the land Z velocity is above the heavy land speed threshold, then we're going to play a, you know, lands heavy. So Let's go ahead and grab a return node off of this and then plug in the and to this. And now we got our setup here. And then let me copy the comment bubble here and place it accordingly. All right, there we go. And now, believe it or not, the next part's going to be easy because we can just literally copy this whole thing, because it's the just landed heavy is going to utilize the same thing. So let's go ahead and create our last pure function called just landed heavy. And I just realized what I did. I'll go back and make that pure and safe, guys. I just thought about it. But with our just landed heavy, we want to get the same data. However, this time what we're trying to compare is we want to change our less than node to a greater than or equals, because what we're trying to check for to see if we are greater than the heavy land speed threshold, which you'll have seen with our Manny character that when we did jump up and down, we hit 704. So they classify that as our just landed heavy and would play the just landed heavy animation. So let's go ahead and grab our return node here and plug in our boolean here. And now we are officially done setting up all of our pure functions, guys. Well, not officially done. I gotta do this first. Let's go ahead and call this pure and thread safe, compile and save that, and then go back into our light. And what we're going to do, or wait, where was I at? I was about to say, because I was like, why is it still on landed heavy? So heavy, there we go. So now we got all of those as pure and thread safe functions. Yep, pure and thread safe. That I don't like that. All right, let's see, pure and thread safe, and that was our just reversed. Should turn in place. Pure and thread safe is pivoting. Pure and thread safe is starting. Pure and thread safe, and I know our is moving is pure and thread safe because we had a long discussion about it in the previous video. So other than that, guys, I know it was pretty long-winded for this one as well. I'm trying my best not to make these long, but what I'm trying to do is get through specific sections at a time, so that way, you know, I'm not having to do small incremental videos where it's like you could have just done this, and it's like getting an email where it's like this could have just been a meeting kind of thing. So we do have all those now, so we should be ready now for the next part where we can start getting into more of the AnimGraph stuff. So let me go ahead and close all these down so we can take a look at what we're going to try to do next, where I'm going to need to do some more research on. So let me pull over the game animation sample project, and in the AnimGraph, we're going to take a look at some things. Like one of the stuff is the offset root bone, because there are more functions that we have to create, but we're gonna re-look at that eventually. You know, we're going to look at the leg IKs. We're gonna set up our pose history. This can actually be set up probably in the next video because we already have our trajectory boolean made, or value made, or a variable made. Then eventually we're gonna start going into mesh space additives. Then, you know, more additives when it comes to lean amounts, and then the actual motion matching database. So these will be videos in themselves, because as you can see within the motion matching that there's more setup. However, there's going to be some things that you notice, like look at that, we got the non-zero velocity, and then we got current database targets, and then, you know, some other stuff. You know, there's more stuff to go into, but look at that, we got the trajectory in here that we'll be going through. So, you know, there's going to be a lot more things to go through. So there's a lot of hidden pieces within this game animation sample project, which I think is really cool, but also kind of annoying. But other than that, guys, I hope you found it pretty educational. I hope you look forward to the upcoming videos. So, you know, if you did like this video, please check out my other ones and look out for my future videos to come. But as always, guys, y'all have a great rest of your day and take care.